Okay, good morning. So we will start our lesson for today regarding radiographic contrast. So radiographic contrast is one of the photographic properties of our radiographic image. Okay. So we will be discussing the controlling factor for contrast as well as the types of contrast and the influencing factor that affects uh, radiographic contrast. Okay, when assessing contrast is one of the two photographic properties that comprises or that is important for us to be able to see the detail.
Sir, narinig po ba kayo? Nakamute po ata kayo.
Yes, ayun. Sorry, nakamute nga. So, ayun, as I was saying, uh, radiographic contrast is one of the two photographic properties when it comes to radiographic image quality. And contrast is important in order for us to see the image. Okay? Or basically, it deals with the visibility of detail of the image in the radiograph. Okay? It is also defined as the difference between adjacent densities. Okay? Two densities, di ba? We have the scale naman. Later we will be showing about the uh, scale. Okay? So when describing contrast, pwede tayo mag-describe ng contrast as either it is high contrast or low contrast. Okay, when we say high contrast, it has few shades of gray. Konti lang yung shades of gray or basically between black and white only. Then, if that's the case, so increase yung contrast niya kasi nga madali nating madi-distinguish yung mga structures, mga adjacent body structures doon sa image or sa radiograph. And we use low KBP for high contrast. Okay? And high contrast is what we call the short scale contrast. Short scale contrast siya kasi there are few shades of gray. Okay? On the other hand, we have low contrast. Okay. So, syempre, kabaliktaran siya ng high contrast. So, there are many shades of gray. Okay? 50 or more. Depende. Okay? Then, decrease ang contrast. Low contrast, decrease ang contrast because there are many shades of gray na halos magkakaparehas na sila ng shade or ng color. Diba? So there are limits to the visibility of detail in the image. So in order for us to have low contrast, high KBP yung reason ng pagkakaroon ng low contrast. Okay? Dahil siya ay many shades of gray, so this low contrast is also uh, manifested as long scale contrast. Long scale kasi marami siyang shades of gray. Okay? Long scale, short scale. Clear po ba? Naintindihan? Any questions? Okay. So in the image, in the slide, we have the high contrast, short scale, and low contrast, long scale. Okay. In the first image, okay, the technical factors used is 50 kbp and 800 MAS. As you can see, okay, the image is much uh, has meron siyang mas maitim na image, and we can clearly differentiate the lung field from the bone. Okay. On the other hand, sa baba, we have a long contrast, long scale. So marami siyang shades of gray. Okay? Makikita natin na some parts of the lung field are uh, black in color. Some are have lighter gray shades or gray shade in color, di ba? So that is a long scale. Okay? If I ask you what is ideal for chest radiograph, long scale or short scale? What do you think is the ideal uh, contrast for chest radiograph?
Long scale po.
Long scale? How about the others?
Long scale din po.
Long scale. Okay, so very good. So long scale. What's the reason? Because we are examining the lung field. Okay? So, kaya kailangan natin ng many shades of gray. So kapag long scale, we will be able to see kung may mga uh, meron ba siyang peklat due to PTB or meron ba siyang pneumonia or may sign ba na may active PTB ang pasyente. Okay? On the other hand, we use short scale or high contrast sa mga examination that concerns with bone, especially do sa mga to rule out fracture. Okay? Okay. So dito, pinapakita dito yung optical density. Okay? At the same time, yung contrast. Diba? From A to letter F. So yung una, okay, as you can see, may contrast wala. Sa letter A na image, may contrast o wala. May nakikita kayong contrast? Sa letter B, may, sa letter A,
Wala po.
wala ba? Meron. Pero,
Konti.
very minimal. Parang nakikita lang natin ay yung vertebrae, hip bone, okay? Tapos, yung ayun, hip bone. And then, of course, the gonadal shield. Okay? Then, sa letter B, ayan, may visible na yung mga structures. Okay? Tapos, letter C, then we have letter D. Okay. So the question is, which of the which of the images in the slide do you think has the ideal contrast or the ideal image? Ano kaya ideal image sa kanila? A, B, C, D, E, or F?
Eh, ano pong ginagawa dito?
Well, let's just say that which of the images has the best contrast? The best contrast. It is the image is a plain film abdomen.
So, ay, yan po yan dito.
D. How about the others?
Sa akin din po, sir. Parang ideal po yan.
Ideal and D. Okay, yung iba? Kailangan ba't ko kayo tinatanong kung anong sa tingin niyo yung ideal or the best image that has the best contrast? Kasi in the uh, sa mga susunod na lessons or sa mga subjects, you will be dealing with images, especially in QA/QC. How will you be able to know what should a good quality radiograph looks like, especially for the different procedure? But abdomen, okay? Kasi ba ayaw sumagot, sinasarili nila yung sagot. Okay? So, paano yan? So, yung dalawa sa inyo sabi, letter D. Okay. What can you see doon sa letter D? Okay, what can you see? You can see the lumbar, lumbosacral vertebrae. Diba? You can see the lumbosacral vertebrae plus a portion of the coccyx. Then you can also see the ribs. Diba? The floating ribs. Ano pa nakikita? You can also see the hip joint. Okay? However, yung pelvis, hindi siya masyadong visible. Yung pelvis. Diba? Okay, if you are going to ask me which image has the best contrast, my answer is letter C. Okay? Bakit? Bukod sa nakikita yung bones, okay, yung mga soft tissues ay nakikita rin. Okay? So nakikita natin yung large intestine, okay, stomach, yun. Saka yung bladder. Okay? So, pero kung ang procedure ay vertebrae, let's say lumbosacral, okay, the best image is letter D. Okay? Yun ang best image natin. Letter D. Okay? So, gano'n. Yung importance ng contrast ay pinakikita dito sa mga images na to, especially when we are looking for a uh, specific disorder or specific diagnosis. Okay? Kaya nga, the best contrast depends of course to ano yung niro-roll out. Tama kanina yung sinabi ni Earl. Na tinanong niya agad, ano pong niro-roll out? Okay. Kapag siya ay, let's say, scoliosis, so kung scoliosis siya, makita na siya sa letter B saka letter C. Okay? Pero kung more than scoliosis, let's say, uh, AS. Ano ba AS? Ano nga yung AS? Or AS. I forgot the AS. So yung nag-collapse yung vertebrae. Okay, so mas visible siya sa letter D. Okay? Okay, so same goes here. So kung makikita natin dito, there are variation in scale of contrast. Okay? So the number of shades of gray, okay, the scale or range of contrast. So increases as KBP increases. So yung shades of gray daw ay dumadami kapag nag-increase tayo ng contrast. Di ba yun yung sabi natin doon sa differentiation between high contrast and low contrast. Tama ba? Okay. So kung makikita natin dito sa dalawang image, okay? Sa letter A and letter B image. Okay. One is taken using a high contrast and one is taken using a low contrast technical factor. So alin ang merong high contrast? Alin ang may high contrast?
Yes, sir.
Hindi po.
High contrast. High contrast, letter B. Low contrast,
A po.
letter A. Okay? So, kung gagamitan natin to ng high contrast ang chest, di ba? Tingnan nyo naman ang difference. Kung may pathology, hindi natin makikita yung pathology. Di ba? Let's say, kung nakikita sa letter A, okay, let us assume that yung haziness or opacity sa left lung, lower left lung, ay let's say pneumonia. Okay? Let us assume na pneumonia yan. Okay? At ginamitan mo siya ng high contrast technical factor. So palagay niyo ba makikita ng doktor o mababasa ng doktor yung pathology? Di ba hindi? Let's say, yung same person yung letter A sa letter B. Same person. Okay? So, di ba ang linaw wala yung opacity sa left lung. Eh sir, ano po yung parang konting opacity doon? So, ayan, parang ano lang siya eh, hindi naman siya opacity, parang shadow siya ng breast. Paano kung sabihin shadow siya ng breast? Okay. Pero syempre, kung radiologist ang magbabasa niyan, reject yan, yung letter B. That's a reject film. Kasi una-una, very dark yung lung field. Hindi natin ma-determine if there are other pathologies sa upper lungs. Diba? Doon kitang-kita yung heart, pero yun na, uh, hindi natin ma-determine if there are other pathologies sa lung field. Okay? Okay. So when we say radiographic contrast, it is the totality or the total amount of contrast, okay, sa ating field. It is the combination of both the subject and the film contrast. Pag sinabing radiographic contrast. Okay? So there are two types of contrast, di ba? We have the subject contrast and the film contrast or image receptor contrast. Okay? Pero kapag ang nakita nyo ay radiographic contrast, it is the sum of both the subject and the film contrast. Yung kabuuan ng pagtingin natin sa image sa ating radiograph, yun yung radiographic contrast. So basically, when we say image receptor contrast, it is the range of densities that are present in the image receptor, or the image receptor is capable of recording. Okay? So that means yung film contrast is inherent sa ating film. Okay? So meron tinatawag na D-log E-curve or sensochromatic curve, also known as characteristic curve, or the HND curve or Herter and dry field curve. So ano tong curve na to? Okay. So before we discuss the curve, so yung image receptor contrast or the film contrast depends on the following factors: the intensifying screen, okay, the film density, of course, characteristic ng film, okay, then the D-log curve or the sensitometric film or curve, and of course the processing, the film processing on paano ba pinaprocess ng radtech yung radiograph, yung film. Okay? So, syempre, una, intensifying screen. Okay? So, kapag ang gamit natin ay tamang intensifying screen, di ba, meron tayong tinatawag na film screen combination. Di ba? So, we only use the correct film sa specific na film screen or IS. Okay? So, when using the correct film screen combination, okay, it will have higher contrast image. Okay? So, it is related to the way in which the film responds to the X-ray photons. Okay? So, yung D-log E-curve, later discuss natin yan. Then, changing screen speed has a negligible effect on contrast. So, okay, kahit na siya ay may effect or factor yung intensifying screen, Okay, negligible lang yung kanyang epekto. Okay? Hindi siya major na nakaka-effect sa contrast sa ating image. Okay? Yung intensifying screen. Okay? Film density. Okay? Film contrast changes with film density. Tama, di ba? Kapag mas mataas ang film density, so definitely, nawawala yung contrast. Pag mas maitim, wala tayong nakikita, wala tayong contrast, di ba? Okay, so there is an optimal range of densities that permits contrast to be visualized at a maximum. Okay, so example nito yung based doon sa ating graph na makikita nyo. Okay, di ba doon sa we have the contrast index and the optical density. So according to the graph, the highest contrast ay naproproduce near the 1.5 optical density. Okay, 1.5 optical density. So the question is, paano natin malalaman yung optical density? So the only way to know kung ano yung optical density ng isang radiograph is to have it scanned or uh, tested by a densitometer. Okay? If the film exposed correctly and the film densities fall within the visible range, okay, visible range of the D log E curve. Okay, so i-discuss natin na yung kung makikita nyo dito sa okay, so this one is the sensitometric curve or the D log E curve. Okay, so the visible range, okay, ang visible range ay yung straight line niya. Visible range. Okay? Visible range siya ng D and D log E curve. Okay. So if the exposure places the developed densities on the toe or shoulder, the slope is not as steep, resulting in a decrease in contrast. So kung titingnan natin hanggang dito, okay, and then pabagsak na siya. Shoulder ng slope sa toe ng slope. So mababa na ang o may decrease na ng contrast dyan sa mga area na yan. So this sensitometric curve is the primary determinant of or ang primary determinant ng sensitometric curve ay yung physical composition ng film emulsion. Okay? Bukod sa film emulsion, ano ba yung component ng film emulsion? What is the component of the film emulsion? Alin?
Allied crystals.
Okay, very good. Siyempre, bukod doon sa gelatin, ang pinaka-importante is the silver alloy crystals. Diba? So, nakadepende yun sa composition ng film emulsion. Gaano ba kalalaki o kaliliit yung size ng silver halide? Okay. So, yun yun. Okay? So as the slope of the curve becomes steeper, so is contrast is increased. Okay? So pag tumaas daw, tumataas din yung contrast niya. Okay, doon sa kanina, film A has a high contrast, narrow latitude film, while film B, low contrast, wide latitude film. Okay? So, kung i-base natin ito dito sa graph, okay, ito yung film A, film B. Kung makikita natin, halos pareha sila. Okay? Halos parehas, pero may pagkakaiba pa rin. Okay? So, film A, high contrast. Film B, low contrast. Wide latitude. Wide yung latitude, narrow yung latitude ng film A. So again, ito yung linear region niya. Ito. Okay. Then the toe region, the shoulder region. Okay. Dito yung visible natin, image contrast. Okay. Itanda niyo pa yung base plus fog level. Okay, so basically ito yung sensitometric curve. Okay? So yung contrast, magiging visible lang siya if doon sa optical density na range na ito. Okay? Say from 1 to 2 optical density. Okay? Pag lumampas, visible pa rin siya pero hindi na siya of image quality. Okay, processing. So developer temperature and immersion time. Replenishment rate, developer contamination, yan yung mga primary factors. So kapag sa manual, nakokontrol natin ang contrast and density. Kasi pwede natin silipin under the safe light yung ating radiograph. Kung may image na. Okay? Kung ano ba, okay na ba yung image? Underexposed pa ba? So sausaw uli. Tapos check uli. Okay? So may maraming chance to develop or to acquire good quality radiograph kapag manual. Siyempre, kailangan pa rin ng use of proper technical factors. Okay? So, on the other hand, kapag naman automatic processor machine, okay? So, yan ay nakadepende sa replenishment rate. Okay, and of course, the developer temperature. Okay. So, what is tandaan nyo pa ba kung ano yung normal range dapat ng developer temperature? Ano dapat ang temperature ng developer? Tandaan nyo pa? Ako hindi nakanda. Balikan. I-review yung temperature, humidity, um, dapat ay huwag makakalimutan. Balikan. Okay? So, ibig sabihin, sinasabi lang na itong mga factors na to sa processing ay makaka-apekto sa production ng fog sa film. Okay. So, as these factors increases, the amount of fog on the film increases and the contrast decreases. So, if you increase the temperature or if the temperature of the developer is too hot, what will happen? Ano mangyayari kapag masyadong mainit ang temperature ng developer?
Masusunog.
Very good, masusunog yung image. Okay. Siyempre, kung sunog yung image, wala tayong radiographic contrast. Okay? So, example, isa pa example, sabi dito binanggit, developer contamination. What do we mean by developer contamination? Halimbawa yung developer na contaminate siya ng fixer. So, ano nangyari? Nahaluan ng fixer yung developer. Okay. Nang develop ka, sa palagay mo ano mangyayari? What do you think will happen to your radiograph? Okay? Ano? What do you think will happen?
Picture po sir ang mahal.
Yes, fixer. Nahalo sa developer. Kaya nga contaminated na yung developer. Okay, so ako nasasagot. Jahi naman. So, what will happen is, there will be no image in the film. Siyempre, kung wala kang image sa film, wala kang contrast, di ba? Bakit, sir, bakit po walang image sa film? Kasi nga, contaminated,
Sorry po.
contaminated ng developer mo. Instead na magde-develop siya, yung film mo ay magde-develop, instead, magiging ang action na ng iyong solution ay fixation na. Mag-a-act na siya as a fixer. Pinapawalang bisa ng fixer yung developer solution. Nakuha po ba yun? Naintindihan po ba yun? Kapag ang developer ay contaminated, kaya po agad maaari ay, halimbawa, kaya sa manual processing, meron silang sarili-sarili niyang uh, paddle panghalo ng solution, pang-mix ng solution. Yung developer paddle pang developer lang. Okay? Same goes with fixer. Yung fixer or yung developer na mapupunta sa fixer, walang problema. Ang magiging problema, kapag yung developer nahaluan ng fixer. So wala nang kwenta si fixer, as a developer, kailangan mong magtimpla ng bago. So yun yung ibig kong sabihin. Okay? Nakuha po ba? Question? So subject contrast. So it is the difference, okay? The difference in the intensity of X-ray beam after it has been attenuated by the subject or body part. So subject contrast depends primarily on KBP and the thickness and type of irradiated material. So kung yung radiographic contrast ay nagde-depend sa film screen, sa sensitometric curve, saan pa? Apat yun, di ba? Film density, saan yung panguli? Ano yung panguli? Hello? Ulit. We have the films, the intensifying screen. Next is the film density. And then the sensitometric curve. Ano yung pang-apat?
Processing po.
Ano yon?
Processing po.
Very good. Processing of the film. Okay. Yun ay sa film contrast. Okay? Kapag sinabing subject contrast, ito lang tatlo. KBP, thickness, and type of irrigated material. Or basically, the density of the irrigated material. So we are not talking about the density na ibig sabihin niya ay blackening, kung hindi density or yung gaano ba ka-dense yung body part. Sabay hollow, sabay dense, or whatever. Okay? So kilovoltage. Okay, because primarily it is the controller of subject contrast. So high KBP, more penetration, more scatter radiation, wider range of densities, long scale contrast, low contrast. Okay? So inuulit lang natin dito yung short scale, long scale. Okay? Then, if you use low KBP, less penetration, less scatter radiation, short range of densities, okay? High subject contrast, okay? Low or short scale contrast. Okay? Clear? May nalilito ba sa high scale sa long scale? May nalilito po ba sa high scale and long scale? Wala. Oh, by the way, examination nyo pala this week. Okay? So your schedule is for this subject ay Friday ang schedule nyo. Friday, party 206, Friday 1, sorry, Thursday. Tama ba? Oh, tama. Thursday 1 to 2:30, party 209, Friday 10 to 11:30. Oh, yun yung exam nyo sa akin. Okay? So, so in continuation, So, amount of irradiated material. So, ayan na yung papasok yung thickness ng body part to be examined and the field size. Okay? Not only the thickness but field size. Paano natin malalaman yung field size? It is by the use of the collimator. Okay? So, ano ibig sabihin? Increased body part thickness or increased field size, okay, will result in the decrease in subject contrast. So that means body thickness, field size is inversely proportional with subject contrast. Okay? Naintindihan po, kapag manipis ang body part at mas maliit ang field size, okay, mas maganda or may increased ang subject contrast. Okay? Okay. So of course, type of irradiated material. So kapag high atomic number, okay, syempre, mas mataas din ang subject contrast. So type of irradiated material is inversely or directly. Inversely or directly. Nako, wala pa rin sumasagot. Kaya na high blood sa inyo si Sir Paulo eh. Tutulog yata kayo eh. Anyhow, so again, irradiated material and the subject contrast is directly proportional. So the higher the atomic number or the density of the material, the higher the subject contrast. Okay? So when evaluating contrast, so the major consideration should be the visible contrast. Okay? So verification that a proper range of densities are visible throughout the anatomical area of interest on the radiograph. Okay. So densities must be within the range of human visibility. Optical density daw na dapat ay 0.25 to 2.5. Okay? So makita natin yung diagnostic range kanina sa sensitometric curve. It is between 1 and 2 or 1 to 2 OD. Proper contrast is not the same for all tissues. Okay, so we should remember that. Okay, bakit? Okay? Kasi dapat we are knowledgeable in anatomy and physiology as well as pathology. Okay? There are considerations in the manipulation of contrast of technical factors kapag may pathology na na-involved. Okay? Or kung hindi man pathology, yung mga treatment na involved such as cast, diba? Cast or ah, ano pa, yung mga implants. Okay? Siyempre kapag in-explain natin yon, so we must use a little higher than the routine. Okay? So 30% density difference has been used as the minimum change. Okay, however, ang ginagamit natin ay the 15% rule. Okay, questions? Selecting the appropriate KBP. Okay, so fixed KBP technique system, low contrast. Variable KBP technique system, high contrast. Okay? Questions?
Ano ba ibig sabihin ng fixed ABP technique?
Okay,
Variable.
very good. So, ito ay technique or system na nakapix lang yung KBP at ang ginagalaw natin ay MAS. Nakapix lang siya sa isang value. Okay? Pag sinabi yung variable KBP technique, so ginagalaw natin yung KBP. Okay? So any other questions? So,
Kaya ako po,
yes.
about po dun sa napag-usapan ng developer kanina yung form na contaminate.
Contamination, yes.
Paano po malalaman, sir, na na-contaminated na yung
Ah, good question. Actually, there are no precaution or hindi precaution. Walang test talaga para malaman natin kung yung ating bang developer is contaminated ng fixer or not. The only way to know kapag nag-develop na tayo at walang image na na-produce. Okay? So ano bang kulay ng or ano ba itsura ng film na na-develop kapag ang developer ay contaminated? Okay. So ang itsura ng film ay
black na po? Ayun po, hindi na-develop.
yes, black. Ay wait, no. Hindi black, sorry. Kasi pag black na-develop siya, ano siya, clear. Clear na blue. May may shade na blue yung film natin, di ba? Kasi kapag ang film ay fresh or kapag hindi exposed ang film, ay wait. Kapag kumuha ka ng film sa box, okay, at na-expose mo siya sa light, ang color ng film natin ay violet. Violet siya na parang frosted glass, malabo. Okay? Pag na-develop siya, itim siya lahat, yung buong film. So, bakit ganon? Kasi na-expose siya sa radiation. Sir, hindi naman po in-expose sa X-ray. Yes, hindi siya na-expose sa X-ray. Saan siya na-expose sa radiation? Sa light. Di ba? Remember that our film, yung film nakalagay sa cassette, hindi naman radiation talaga yung tumatama or hindi naman talaga X-ray yung tumatama sa ating film, di ba? Light photons na siya, di ba? Tama ba? Light photons nga ba?
Exposure ng the eyes.
Yes, very good. Okay. Buti naalala nyo pa. Okay? So yun. The only way na malalaman natin is kapag nag-develop tayo, walang image na lumabas.
Sir, question.
Yes.
Lagi pong ganun pag po bababa. I mean, hindi po dapat increase parehas ang KVP and MES. Pag po low yung KVP, dapat po mataas yung MES and vice versa po. Tama po ba?
Yes, tama. Kasi kailangan i-compensate at di ba compensate kasi nga when you increase MAS, bababa yung contrast niya. Kasi bababa yung contrast, mas iitim yung film, di ba? So, maaaring bumaba ang contrast kapag tinaas mo ang MAS nang hindi mo binabago yung KBP mo. Kaya nga dyan papasok yung ating 15% rule. Para same pa rin siya ng density, okay? Yun nga lang, ang i-adjust natin is the KBP and MAS. Okay? So when we increase 15% ng KBP, anong gagawin natin sa MAS? In order to have the same same density, film density, idodouble ba? Nag-increase tayo eh. Anong mangyayari? Kapag increase ng 15%
So, i-decrease po yung MES by
ng
half po.
very good, by half. Pag naman nag-decrease tayo ng 15%, saka tayo magdo-double ng MAS. Tama ba?
Opo.
Okay. So, may question pa? Okay. So yan, okay. Okay, dito makikita nyo, iba-iba sila ng technical factor na ginamit. Okay. Sa skull, saka sa uh, thoracolumbar, lumbosacral. Okay. So, sa lumbosacral, of course, you can see na maganda yung radiograph niya, yung letter D. Okay, that is the ideal radiograph. Okay. Ayun, tumatawag si Dean. Okay. So, dito naman letter A. Ayun, kita yung sa may frontal bone. Okay. Sir, bakit po itim yan? Okay, may frontal sinuses po tayo. Wait nga lang, sagutin ko lang si Dean. Hello po, ma'am. Hello, ma'am.